Okay, good evening, everybody. I'm just watching as we're letting attendees into this meeting. We've got 30 people signed up at the moment, and there's just 10 that have joined us. But as it is 7 o'clock, we will make a start. I'd like to welcome you to the first of what I hope to be many ground source heat pump information sessions brought to you by the National Ground Source Heat Pump Association. I'm Andrea Ellison. I'm the chair of the marketing committee. I'm the treasurer and the director of the association. And this evening, myself and Stephen, our secretariat, are introducing you to Dave Jones of Hafod Renewables in Denbigh and Geoff Ellison of Dragon Drilling in Corwen as our local members who are experts in ground source installations. Before I do that though, can I just let you know that you can put questions into our Q&A section at the bottom of the page. If you go to the bottom of the page, your arrow should show you a Q&A. If you press on that, you can put the questions into that section, and I'll be monitoring that so that I can ask the questions to Geoff and Dave once the short presentation has been made. Just to let you know that this session is now being recorded and it's being broadcast live onto YouTube. And it will appear on the Ground Source Heat Pump Association webinar page with links to the YouTube channel, should you wish to watch it at a later date. So with that, we've now got 16 attendees, I can see. I will now hand you over to Dave Jones, who's going to do a short presentation for you. Thank you.
Okay, right. Well, welcome everybody. I'll just do the technical bits. Everybody see that? Okay, I'm Dave Jones of Hafod Renewables. So I'm just going to run through this short introduction to ground source heating. I'm going to keep it simple. And then myself and Geoff Ellison from Dragon Drilling will answer any questions you want to put to the question tab. Okay, so first of all, what is ground source heating? Just simply, so ground source heating can be used in many homes, and it is used in many homes and businesses across the UK, primarily for space heating and domestic hot water. Can be used for process heating, but it's primarily used for space heating. And then these two items at the bottom are a ground source heat pump. So these are what provide the heating and hot water in the homes. So this is one on the left. This is how the manufacturers show it to be, but in reality on the right, this is how they look in a home. This is quite a large complex installation, so a bit more pipes and cylinders and etc. So how does a ground source heat pump work? I get asked this a lot really, and it's quite hard to explain in one slide, but I put this together. And so this is shown as a borehole, I suppose. So heat from the ground is absorbed by circulating a special fluid around this ground loop buried in the ground. So if this is a borehole, this would be 100 meters deep. So I've shown here that the average ground temperature can be anywhere from 8 to 12 degrees. And it's that energy that we're extracting. And to do that, we run a special fluid through the pipework, which is actually going out at -3. It's very coolant fluid, and then returning at 0 degrees to extract that temperature. So that's what we've got going into the heat pump, and then there's a special compressor and a refrigerant that turns that into a superheat, which can give you 55 degrees to your hot water, and up to 55 degrees. You can actually, the higher temperature ones can go up to 65 degrees, but generally with underfloor heating and radiators, 40-45 degrees, it gives out to the heating system. So that was more of the complex. It's basically how efficient are ground source heat pumps, so that they can provide a system efficiency of up to 400%. So compared to a gas or oil boiler run at 80 or 90%, they're very efficient with regards to efficiency. So generally, this is how they work. A bit simpler. So you put 1 kilowatt of electric in to a ground source heat pump. You get free energy from the ground. So in this case, it's 3 kilowatt comes from the ground, and you get 4 kilowatts of heat out. So the conversion is 1 kilowatt in, 4 kilowatts out, and that's how you get to the 400% efficiency. So the free energy. So for every 1 kilowatt they consume, up to 4 kilowatts can be delivered. So there's different types of ground source collectors. So these are the pipework that gets connected to the heat pump. So in both these cases, the ground source heat pump is the same, but on the left-hand one, this is done via boreholes. So this is a drilling rig that will drill down typically 100 meters in a 6-inch hole, 100 meters deep. And this one on the right is a horizontal collector, where you're only digging down 1 meter deep. And typically you need a quarter of an acre, 600 to 800 meters of pipe for a domestic house. So a lot more area needed in this installation, whereas boreholes, a lot of houses only need two, maybe 3 boreholes. So you're only taking minimum space, so 3 6-inch holes, as opposed to a lot more space for horizontal. So that was, again, in practice. We got the horizontal on the left. It takes up quite a lot of space, really. A lot of people ask, can I put it in my garden? And generally I always show them this picture, just to get a feel of how much space you actually need to put a horizontal loop in. So it only really works in fields, paddocks, where you've got plenty of clear space away from trees, buildings, etc. So on farms it works really well, but you do need a lot more space. And then this is the borehole footprint. There's not much to show with boreholes, because everything is in the ground. This is literally all you can see. So this is the 6-inch circumference of the borehole, and then it's showing the 2 pipes, the probe that's pushed down to up to 100 meters deep. So both can work with the ground source heat pumps. Boreholes more efficient, warmer temperatures below and less space, whereas horizontal, more space needed, cheaper to dig out, but slightly less efficient than boreholes. So going on to the drilling rigs now. So with the boreholes, it's specialist equipment, specialist companies, Dragon Drilling, for instance, can drill down. So you can't use any sort of drilling rig. It's got to be a specialist rig. So that's a picture of the rig on a job. They can be tracked to remote locations easily enough. They require an access width of typically 13 foot, so a standard gate they'll tend to get through. And they're suitable. We've done jobs in large gardens. As long as you've got the 6 meters away from the house, that you can put them in quite tight spaces, really. So they require the 6 meters away from the houses and buildings. And if you're going for more than one borehole, boreholes have to be 6 meters apart as well. And generally, no planning permission is required for the borehole drilling. Okay, so this is the internal bit, the ground source heat pumps in the homes. So generally, you need a bit more space than an oil boiler or gas boiler on the wall would take up, because we've got to fit these ground source heat pumps. So these fridge-looking things is the ground source heat pump, and they tend to. This one on the left is a larger complex, larger house. We've got a larger hot water cylinder, a buffer cylinder, and a few more zones and things. So from one extreme, this is probably the largest sort of room you need in a house. On the right, they can come more compact. This ground source heat pump needed a bit more space because we've got 180 litre or 200 litre hot water cylinder built into this heat pump, so less space needed on the integrated ones, but still a bit more space in the boiler. So that needs thinking about where these machines are going to go. So is my home suitable? Get this asked quite a lot, really, and generally 98% of properties ground source can be retrofitted to many properties if you've got the space for the boreholes, that is, but internally, as long as you've got pipe work and radiators, We can tackle most jobs really. We connect to the existing radiator system in most cases, and it might just need the odd radiator replacement to cope with the lower temperatures of ground source. So again, we need space of 2 to 3 square meters required in a home, or an outbuilding or a garage is ideal. Properties require cavity wall, filled insulation, and loft insulation to 270. So this is if it's a renewable heat intensive project, we need filled cavities and loft insulation. If it's a stone property or a solid wall with no cavity, then you don't actually have to fill them. You still can qualify for the renewable heat incentive, but it's only if you have a 1970s or early 80s build with a cavity that's not filled, they need filling. So some of the advantages of ground source heat pumps I've listed. So yeah, low maintenance, they're very, very low maintenance. They're clean, safe heating system, no burning of fossil fuels, no requirement for fuel storage. They're a constant, comfortable temperature all year round. Low running costs, long lifespan. So once they're installed, they'll last for sort of, I mean, the heat pumps will generally last 25, 30 years, but the ground collectors, the infrastructure that you put in for the collectors can last up to 100 years. Once they're in the ground, there's very, very little to go wrong. There's a good renewable heat incentive available at the moment that will be running until March 2022. That can pay you for all the heat that you produce. And then there is 5% VAT on domestic projects as well, so that's quite a saving against an oil system as well. So the picture, so yeah, no more fuel tanks, no LPG, no requirements for any tanks. You generally free up a lot more space in the garden when you switch to a ground source heat pump. And then these graphs here are just talking about the constant comfortable temperature all year round. We've got the ground source here on this example. So the ground source generally gives out stable temperature around about 20 degrees, 21 degrees in the home, irrespective of what the outside temperature is doing. The heat pump will generally give you all the temperature. Whereas oil boilers, a lot of people run them and they have this sawtooth effect because you couldn't afford to run a boiler 24/7. They're designed to come on to heat in the morning for a few hours, and then the temperature drops in the day, and then people come home, it comes on again a couple of hours off in the evening, on in the day, and you tend to get these swings in temperatures with boilers. Whereas with ground source heat pumps, you don't really do that. You have a constant temperature, so it's a lot better for the home and for occupants as well, a lot more comfortable. So grants available. So the domestic renewable heat incentive is available at the moment. Again, for another year, it's running, and you can qualify as long as you can get an EPC, Energy Performance Certificate, on the home, which is 99.9% of property. If it's a home, you will get an Energy Performance Certificate. The payments are based on that EPC as well, so you need to get an EPC assessor to assess the home, give an EPC, and then that's how the payments are based on the EPC. So the current rate is 21 pence a kilowatt hour. So that's what they pay you per unit of heat. So I tried to, and payments are paid quarterly over a 7-year period. So what that 21p means, so typically for a 3-4 bed house with cavity wall insulation, you can typically get up to £18,000 back off the RHI grant, paid over 7 years. And then you've got the other end of the spectrum, which is old period farmhouses or stone houses, anything with not much insulation. The grant is up to 34,000. It works out, so you can get a lot more for older properties because they need more heat. You get paid more of this 21p of heat. Okay, so yeah, in summary, the ground source heat pumps can be a good choice environmentally and financially for homes and businesses. Homes off the gas grid are generally more suited to the technology. We find we're finding we're doing more gas properties at the moment, but generally with the costs of oil and LPG and the storage, they do suit the rural sort of properties who are connected to LPG and oil. The domestic renewable heat incentive is available until March 2022, and it is a fantastic program. Just going back of what you can earn off the last page, and many times people are earning £4,000 to £5,000 a year for 7 years. So it is a good scheme, and it generally covers the whole cost of installation, because you generally have to find the money up front or fund it yourself, but the RHI will cover the installation costs. As ground source heat pumps provide a constant heat, they're suited to homes occupants that would benefit from more continuous heat rather than intermittent. So this is what I hear a lot, especially in older properties where the boiler has to, it's coming on maybe a couple of hours a day, a couple of hours at night, and there's cold times in the home. Whereas with ground source heat pumps, you don't get that at all. The heat pump's given a constant temperature because that's how they're designed. Other technologies can be integrated as well. So this is sort of I think the way the governments want people to sort of go with all, integrate into all the technologies. So I mean, things like solar PV and battery storage can help offset the running costs and work alongside. We've got smart meters now. We can get better tariffs, cheaper tariffs to be designed with heat pumps to save even more money. And then with all these things, so we're getting into one fuel for the home, and this is the sort of future that we're seeing people are going for. Okay, so yeah, that's the slideshow finished. So questions invited, really. So I'll take all the heating ones, and Geoff Ellison will take the drilling ones. So thank you for listening.
Okay, thank you very much there, Dave. That was very good. I've got no questions. Nobody's put any questions into the Q&A box. So if you could go to the bottom of your screen.
Could I just interrupt you there, Andrew? There is a question, sorry. It's in the chat screen. It says, is there an alternative to having a 13-foot wide drilling rig? Couldn't get that onto my property.
Well, that's one for me. Yeah, I'm afraid drilling rigs are fairly large. Our smallest one, you might squeeze into a 12-foot gap, which is an ordinary size gate, but you do have to get access to the property. So I'm afraid if you've only got 13 feet to play with, that's about all we can do. We can't shrink the rig any more than that.
Okay. We've got a couple of questions now coming to the questions. So Trevor's asking, is the borehole lined, or if not, what is it foiled with?
The borehole will be lined in places where the borehole may collapse. When you're drilling, if the bore's collapsing, then you'll put steel case in there to hold the bore open. But after you put the loop in there, the heat transfer loop, you'll backfill the borehole with a special thermally enhanced grout, because you want good contact between the plastic tubing and the surrounding environment. So the borehole is backfilled with a grout under pressure to ensure a good contact between the heat transfer media and the surrounding environment. So we don't leave things in usually, but we do backfill it with a grout to make it a good contact area. Okay,
I've got Seb asking, how long would it take to drill a typical 100-metre borehole?
We'll do that in a day, easily.
Okay. Caroline's asking 2 questions here. Does the machinery make a noise when it's running? And when installing a horizontal system, what happens about the land drains? So does the machinery make a noise?
Geoff, one for you, yeah, Geoff?
Well, there's two machines. I think the first thing is, does the heat pump make a noise? Well, the answer to that is no, it doesn't. They're nice and quiet. I've got one, and they're quiet. In fact, some are so quiet they need a light on to say they're working. If you're doing drilling work, yeah, there is some noise associated with drilling. We try to minimize it. We have tier 5 engines on our equipment. We use electric soft generators wherever possible, but there is some noise. And if we're using a hammer, then that does make a piling type noise. So there is some noise when we're doing the drilling. but we try and minimise that by doing it quickly.
Okay, and the horizontal system, what happens about the land drains?
Yeah, I suppose we do various jobs. So land drains can be a problem. So we just got to do some test holes and try and avoid them really. Because them land drains are there for a purpose. We don't want to be running over them with loops really. So we've had maps of the field maybe where they've got some historic data and tried to avoid them. But yeah, if there's land drains in, we don't really want to be digging big 1 meter trenches through them really. So best to avoid. So we need to know where they are and dig away from them really.
Yeah, it's the same with the drilling, isn't it? The CAT scans and all sorts, looking for underfloor resources. And Caroline's asking as well, she's on gas at the moment. What happens about the gas Arga?
Gas, keep using it, I would think. It's a separate supply, it's a separate system. Use your gas Arga and have a renewable system on your heating.
Yeah. Okay.
Yeah. As long as it's not doing, as long as it's not doing the hot water. If it's doing the hot water, then it's just a decision to make. If it's got a back boiler doing the hot water, then it's just a decision to make whether to run it off the gas Arga or switch it over to the heat pump.
Okay. Dave, can you switch off your share screen, then people can see you?
Oh, right. Okay. Switch off the whole thing.
Okay.
Hang on. Yeah. Stop share. Okay.
Okay. Right. Stephen Hall's asking, is there a chance of replacing non-domestic RHI system in a small farmyard properties, which is 3 properties heated by biomass and 2 2,000 litre buffer tanks with a grant? Also, we have a 27 kilowatt solar array.
The chance of replacing a non-domestic RHI system. So I'm guessing heating by biomass. I mean, the non-domestic tariff has now, well, in the next week, has now finished. So unlikely unless you can change. I think there were some rules. If it's a non-domestic site, it's going to struggle to get back to domestic because it's been classed as a non-domestic site. You'd have to maybe send me a separate question for that. That could need quite a lot. There's quite a lot of variables involved there. Yes, if you want to take the Andrew's email or info at GSHBA email and email in on that, that's not as easy to answer.
Okay, so we'll deal with that one. So, and Tom's asking, has the heat pump technology improved for heating older properties? Well, being the owner of an older property, I can put my hand on my heart and say absolutely yes.
Yeah. The heat pumps, they can give out 55, 60 degrees. So as long as we get the radiators to size, in most cases, generally people can have the radiators. It will give out the required heat. Yeah, so I think, it used to be a little bit more of a myth, maybe, that they won't work in older properties. We're doing older properties day in, day out, and Andrew's got older property that was one working in, and they work just as good in older properties. It just means they're on for longer periods, really, which is what they're designed to do. So, yeah, no problem with older properties, but it is a case of getting the radiators right and making sure you got the heat output.
Well, I'm sitting in the older property. This property is 400 years old. So there's no cavity wall. They weren't invented when this property was built. Got a high thermal mass, and the transformation in this property from being a very cold property running on kerosene to being one that's nice, cozy and warm. So I'm spending less money now on energy than I was when I was running on coal and kerosene. The house is a lot warmer, and the RHI makes a contribution. So my view, it's a triple winner on that one.
Okay. Can the heat pump heat water to 60 degrees C to satisfy the Legionella function?
Yeah, a lot of heat pumps can need a flow temperature of about 65 degrees. So some heat pumps can go up to 65 degrees quite easily to heat the hot water. Some heat pumps only give out 55, and then the raise to 60 has to be done with a backup immersion heater. So either way, the Legionella's passed. So it's not a problem. So we either do it with a little bit of immersion, or some heat pumps can actually heat to 65 degrees. no problem.
Okay. With regards to the hot water, I can promise you that if there's a bath done in my house or we're washing up the water, I do still need to put the cold tap on. I know lots of people ask about, does the water get up to temperature? I can promise you that actually, yes, it does. Most definitely.
Plenty. Yeah.
Okay. I don't have any more questions. We've got a little visitor there. I don't have any more questions showing. Has anybody got any more questions? If you pop it into chat now. Don't see anything else. No. Okay. Okay. Well, if you do think of anything else, Stephen's put the email address into the chat for everybody, which is info@gshp.org.uk. As I said at the beginning, this is the first of what we hope to be many Q&A sessions for people who are just maybe interested in using ground source and just want to know a little bit more about it. But please, do email in. Do go onto our website, www.gshp.org.uk. Just be reminded it's not gshpa.org. That's the Girl Guides in California. So it's gshp.org.uk if you got any questions. We've also got our annual conference coming up in October, the 22nd of October, and that will be in Skipton in North Yorkshire. Details of all of that sort of stuff is on the website, so please do have a look, go and find out information from our website, and any questions, email in. So thank you very much everybody who's attended.